mute button just to eliminate any background noise, which can be distracting. And for those participating via Zoom, if you have questions, I'm going to ask that you type them into the chat box. We've got too many participants to do this live, but I'll try to reserve time at the end to answer any questions. So type them, if you would, into the chat box. The way to do that, if you're not familiar with it, there is a label down at the bottom of your screen which says chat. Click on chat. That opens a chat box. Over in the lower right, type your question into the box, hit enter, and it goes into the stream. This is intended to be an hour class, and I'll try to keep it to an hour. There's so much to cover, really, but this is a basics class, and I'm going to try to keep things as basic as I can. And it is, I sense that we have some people who are more experienced in astronomy, perhaps some more experienced than I am, but I'm pitching this really for the beginner, the newcomer. I'm the current vice president of the San Francisco Amateur Astronomers. You see my name is not SFAA Astronomy, it's Bill Kircher. I logged on as SFAA. And I've been a member of the club for a while. I've had a long-term interest in astronomy. One of my main qualifications to do this is that I did it the wrong way when I started out. I was in a big hurry. I wanted a telescope. I wanted to use tech. I wanted to use GoTo. And I had to go back to the basics eventually because I wasn't able to use tech to solve too many of my problems. And it really is important to just start with the basics, get those down, and then build on that rather than getting too far ahead of yourself. So, big subject. Navigating around the night sky, big subject because the night sky is a big place. And if you are a newcomer, when you look up, you see stars, you see the moon, maybe you recognize the Big Dipper, but what's all the rest of this? Stars. I mean, how do you make sense out of it? One step at a time. Like when you move to a new community, you don't try to learn every street in your new community, you start going places. And it starts to make more and more sense to you, and you build on what you know. Let's say you're looking for a Home Depot, and you realize that it's on the way to Target. You already know how to get to Target, so you just take a left turn before you get to Target, and you're at Home Depot. Same way with astronomy, really. Tonight, we're going to focus on bright stars, easily recognized patterns of stars, and some mnemonics to help us remember the rest of it. And I hope that at the end of this, you will know how to find the 16 brightest stars in the Northern Hemisphere sky. If you know that, you also know how to find 16 constellations, because each one of those stars is in a constellation. But we're starting with the stars because they are easy to find and they're bright. The constellations, not so much. You find the constellations most easily through the stars. But if you know how to find a certain star, you know how to find the constellation it's associated with. It's sort of like saying, if you know how to get to Boise, you know how to get to Idaho. Right, that kind of thing. All right, so I'm going to share my screen now, because most of this presentation will be through PowerPoint. I wish we could go outside with a laser pointer, but we can't. So I've done my best to recreate the sky virtually. But first we have a few preliminary subjects to cover. So all right. So I'm finishing up the introduction. I'm going to next go to an overview of what's up there in the night sky. I'm going to try to put everything in 4 categories to sort of simplify it. I'll talk briefly about some navigation aids. Tonight, we're talking mostly about just using your eyesight, your unaided eyesight. But there are a few things that are helpful even if you're just using your eyesight and not a telescope or a more sophisticated set of binoculars. I'll spend a little bit of time talking about the layout and the motion of the night sky. The sky does have the equivalent of highways, at least 2 of them. And it does appear to move. Of course, we know now that it's the Earth that's moving. The stars are staying put. For a long time, people thought that the Earth stayed put and the sky moved. But regardless of which it is, you do need to know how the sky moves, both, or appears to move, both over the course of a night and throughout the course of the year. And then we'll be on to our virtual tour of the night sky. We'll start with the winter and work our way through the seasons, seeing the bright stars and the highlights of each. And then I'll end with some next steps. In other words, where you can take things from here. Okay, first, overview. Here's the 4 categories: the stars, the planets, and then something we call the deep sky. Sometimes we refer to this as the faint fuzzies because these objects are faint and they're fuzzy. We can see some of them sort of with our naked eyesight, better with binoculars, but for most of them, you need a more advanced astronomical instrument, which we'll cover in our second session next month sometime. And then everything else. So let's go to the 16 brightest stars. Now, these are the stars visible from the northern hemisphere. There are some even brighter stars in the southern hemisphere, but we're in the northern hemisphere. And I've arranged these stars in order of brightness: brightest at the top, dimmest at the bottom, and the bottom's not dim, it's still a bright star. And then I have in the middle column the apparent magnitude. Magnitude means in this chart apparent magnitude, relative magnitude to an observer on Earth. The smaller the number, the brighter the object. So Sirius at minus 1.4 is clearly the brightest, whereas Castor down at the bottom is still bright, but not as bright as Sirius. These are all relative measures. Constellations are listed in the right column. Again, you'll get familiar with these soon enough. As I said, if you know the star, you can find the constellation. So we're going to focus on those stars, easy to find. Constellations are not easy to find unless you know where to look and have a bright star to help you. Okay, so these are not all visible in one season. They actually are visible in different seasons of the year. And when I say visible, I mean most convenient to see during convenient observing hours. Sure, if you want to go out at 3 o'clock in the morning, you've got more options, but most of us don't. So the blue would be the ones that are convenient to see in the winter, and then the spring, I have that in green, Arcturus and Spica, summer in red, and autumn in gold. Moving on to the planets, I have a list of the brightest planets, not all of the planets. There are 8 planets, and Pluto's now a dwarf planet, but 8 full planets, 2 of them closer to the sun, Venus and Mercury, and the others beyond.
1/100th to 1% of the top 10%, I mean, the top 1%. There's a problem. The Wall Street.
Can anybody else hear? Sounds like some.
Someone needs to go on mute.
The 1/100th to 1%, the top 1%. There's your group right there. They can
A little bit of interference.
Burst everything. So these gangsters.
Okay, I'm going to have to stop the share for a second.
They have reasons.
That's on iPad.
It used to grow economies and benefit Main Street workers.
Okay. Back to share the screen. All right. So we're back to the brightest planets. This is the maximum apparent magnitude. The moon obviously is clearly the brightest, minus 12. Remember, the smaller the number, the brighter. Venus, though, is very bright, but it goes around the sun in its own orbit. It's not always bright. This is the brightest when Venus is at the most the best viewing angle from the Earth in terms of brightness. Jupiter, Mars, both very bright. Last summer, Mars was incredible. It was clearly the brightest object in the sky for a while, other than the moon. Mercury, quite bright, but hard to see because it's so close to the sun. Saturn, still fairly bright, but you can see not nearly as bright as Jupiter. The two outer planets, you really can't see them with your naked eyesight. Maybe with binoculars, you can get a hint. They're just too far away. Okay, now we're on to the faint fuzzies, the deep sky objects. I have two on this screen. One is nebulae, the plural of nebula. Nebula is basically gas and dust. There are different types of nebulae. This one I have in the left side of the screen, the box on the left side of the screen. That is the Orion Nebula. It's a bright nebula, beautiful. You can see it with your naked eyesight, a hint of it. This was taken through a telescope, of course. And there are other kinds of nebulae as well. On the right, I have an image of a cluster, a star cluster. That's a lot of stars in a small area. This happens to be an open cluster. These are new stars. Open clusters are sometimes called star nurseries. They're in an area where there's a lot of gas, and optimum density and temperature for star formation. And this is something that you can sort of see the fuzzy part of it with your naked eyesight. Binoculars, you can really start seeing something. And then, of course, even more with a telescope or astronomical binoculars. So two deep fuzzies, nebulae and clusters. There's also something called globular clusters, a little different, older stars. I'm not going to spend too much time on this because at the beginning, these things are hard to see. I just want you to know they're there. Another faint fuzzy is, of course, another category is galaxies. On the left, we have an image of our galaxy, the Milky Way. And this was taken at Point Reyes. It's unfortunately, you won't see this from San Francisco, but if you go a ways away, you can see our galaxy, the Milky Way. We are looking edge on here towards our galaxy's center. We are in an outer arm of the Milky Way, a spiral galaxy. Most of the stars, or these individual stars we see, are all in our local arm of the Milky Way galaxy. But when we look towards the galaxy center, then we start to see this glow, which is all these hundreds of millions, really, I think more than a billion stars in our galaxy, as kind of a fuzzy glow. On the right is the Andromeda galaxy. This is an image I took. I was actually trying to take a better picture, and I had to do a screenshot over my cell phone. And I put this up here because this is sort of what you would see through binoculars, not this bright. It's a spiral galaxy like ours, but when you see it through binoculars, you just sort of see this fuzzy haze around it, unfortunately. Astrophotography, better setup, you can start to see the spiral structure. So that's a taste of the deep sky objects. All right, so let's now talk just very briefly about, whoops, I've skipped over something. No, I haven't. Okay, so we're now to the fourth category, everything else. So I've got four categories: meteorites, comets, asteroids, satellites. Meteorites is sort of the common way of referring to meteoroids, which are mostly what we see. They're very small pieces of almost sort of closer to dust than rocks. Leftover debris from comets. And the Earth passes through what they've left behind, and it creates this appearance of shooting stars, which you see on the left. This is a time lapse of the Perseid meteor shower in August. Comets, we had one last summer. Neowise generated a lot of excitement. Here is an image taken by one of our members. Not pictured, asteroids, which vary in size. Whoops. Vary in size. Some are the size of rocks. Some of them are bigger. Some of them are approaching dwarf planet size. Most of them we can't see. To see them, usually you need at least binoculars or something better. Satellites, there are a lot of them, more and more, I'm sorry to say. There more are planned, but you can see satellites moving very quickly, and you can also see the International Space Station when the sun catches it at the right angle. Again, I'm going to keep the focus on stars because you can't find your way around looking at meteorites or comets or asteroids or satellites. They come and go. Stars are always there. Okay, so that's an overview of what's up there in the night sky. Let's go briefly now to navigation aids. This is important. A map of the sky really comes in handy. You can find things on the internet, and you can find this on the internet at skymaps.com and print it out. Available for free, printable version, one map every month with some information about events during that particular month, what the moon is doing, and so forth. I've used this as part of my PowerPoint, and I'll show you how I'm using it when we get to other slides. Very handy. Remember, when you look at this map or any map, you're looking up. You're not, mostly we look down at maps because the ground is below our feet. The sky is above our heads. We're looking up. So with any map, you hold it up at eye level or above, and imagine the flat part as being above you, not below you. So this is oriented, see down at the bottom, south. So you would be looking south. If you want to look north, turn it around. You have north at the bottom, hold it up. All right, here is something called a planisphere. This is really handy, not expensive, and it is something you can use year-round, shows the position of the stars and some other things. And what you do is you line up the date and time on these outer circles. So see my little red dot down here. February, let's say we're at February 13th at 9 p.m. down here in the lower left part. We're looking north. So this is overhead. We're going to hold it up and face north, which will make east to our right and west to our left. This little grommet here, that's supposed to be the north polar axis, the North Star, around which everything rotates. And we'll be doing that a couple of times, but that's basically the idea. This is a two-sided planisphere. It has another side. If you're facing south, there's a reason for this. So because when you try to take something that's round, like the sky as a dome, and make it flat, you get a distortion. So this tries to correct for that. So the southern part of the sky is on the other side. So this would be the actual horizon. You're holding it up above your head. This is the horizon looking south, and then above this would be the other side, the north part of the sky. Okay, there are other maps. There are maps in magazine, maps and books. I was going to cover all of that, but I can't fit it all into an hour. Suffice it to say, astronomy magazines like Sky and Telescope or Astronomy have monthly maps and a lot of detail that you won't find on, say, a planisphere. But I'm over now to a different kind of map. These are computer maps. Stellarium is available. It's a planetarium software that you can run on your computer. It's free. It's great. It's like having your own personal planetarium. A little bit of a learning curve, but once you get familiar with it, it's a piece of cake. And some of the screenshots tonight were made from Stellarium. And then, of course, apps for your phone. We're talking about navigation. Well, there are navigation apps for your phone too. Two of the popular ones, which I use, Sky Safari and Sky View. So this on the right is a screenshot of a view from Sky Sky Safari, actually Sky Portal is a customized version of Sky Safari that came with my telescope. And you can see it showing constellations, showing Orion. It's really a nice app. Sky View I like because it uses your cell phone's camera. So if you hold it up to something, you want to know what it is, and you get that object in view, then you can just tap on your cell phone screen and the app will tell you what you're looking at and confirm. Hopefully you already know, but if you don't, it confirms what you're looking at. Don't place too much reliance on these. Like maps, these are small. The sky is big. You will be amazed when you look at a map and then look at a sky at how much different something looks in the sky, because you forget how big the sky is, how big something like Orion will look when you look up. Cell phones can only cover a small part of the sky. That's why you need to be familiar with the sky and look at a map that will show you more of the total sky. All right. A couple of other navigation aids, red lights. Regular flashlights ruin your night vision. So these are dedicated red lights, a variety of them, including a headband one that you can get at a hardware store, protect your night vision. If you don't have anything, you could put some red cellophane over a flashlight, or even I'm told you could put a paper bag over and secure it with a rubber band. Okay, binoculars. Don't go out and buy binoculars if you don't already have something available. We'll cover that in the next session. This is what I found around the house, though, that I use. Some smaller binoculars I use for hiking at the top, larger ones that are actually boating, marine binoculars, but they work fine. Over on the left, a little nifty little attachment you can use that screws onto the front of the binoculars and acts as a bracket to mount these on a tripod, because that will steady your image. It'll make it a lot better. If you don't own binoculars, as I say, don't buy them. Maybe somebody can lend you some. They will enhance your experience, but they're not essential. All right. So let's now talk about the motion of the night sky. How does it appear to move? This is an image taken by one of our members, time lapse, I think probably at Mount Tam. And it shows star streaks. So time exposure, the stars move a bit and they leave a streak. And what you see here is a circular motion as you get closer to the North Star. So here is the North Star, I would say, judging by the streaks right around here where my little red dot is. And then these stars closer seem to revolve. They're going to go counterclockwise, always counterclockwise. When you're looking up to the north, counterclockwise. You get out here and you see these stars actually are going to set. They're going to go down below the horizon. So the motion of the night sky is really east to west, which makes sense because during the day, that's what we see with the sun, east to west. The sun rises in the east, it sets in the west. Stars do the same thing at night, east to west. Now here's our trusty planisphere where I've illustrated this. There's this circle around. So the grommet is the North Star. And this circle around the North Star where things appear to move in a circle. You won't see the whole circle, even if you keep going out or stay out all night, because at some point the sun will come up. So you won't see the whole thing, but you'll see a good part of it. So around, and here are these constellations inside this circle, these are going to be circling. They're almost always visible because we look up towards to our polar axis. Stars outside that circle, no, they're going to rise in the east. Here's Arcturus over here. It would have risen in the east, and it's just going to continue around and go down and set in the west. Everything here is going to do that, east to west. 1 degree of movement every 4 minutes. You won't notice it just staring at the sky. You'll notice it if you get your camera out and try to take a time lapse, or try to keep something in the field of view of your telescope. But if you let's say went inside and came back 2 hours later and you had a frame of reference, you would definitely see things had moved by 30 degrees in 2 hours. Okay, so in addition to the movement over the course of an evening, the stars also appear to move as we make our journey around the sun. Every year, we go around the sun once. And tonight we're going to start with winter. So here's the winter over at the right. Now, the Earth is tilted, and you see the axis in pink of the Earth's tilt. And the Earth goes around, rotates in a kind of counterclockwise direction. That tilt stays the same as the Earth goes around the sun. So if you're looking up at the North Star, you're looking straight up to see the North Star, or virtually straight up. Over here, in the spring, you're still looking straight up. The North Star is so far away, you don't notice the angle. You're still looking at the same star. You can still see it. Over in the summer, same thing. You're looking up, you can still see the North Star. But there are some things you won't be able to see. So if you're looking, let's say we're here in the winter and you're looking out towards the right at something. Well, you've got a good angle at it. You just look out and see it. It's not up here with the circumpolar region, that circle I showed you around the axis of the pole axis, but you can certainly see it out here when it's nighttime because you're looking to the right. But when we get around to the summer, you're looking the opposite direction. You're looking off to the left on this diagram. You see a whole different sky. The north sky is the same, but what you see out here is different. The problem is that what you were seeing in the winter at night now would only be visible during the day, so you can't see it. That's why the winter star and the summer star are different. And the Earth is always moving. It's making that trip around the sun once every year. And what that creates is the appearance that, remember I said the stars rise in the east and they set in the west? Every day they rise in the east 4 minutes earlier. And it adds up. In a month, that's 4 times 30, that's 120 minutes. That's 2 hours. That's a 2-hour difference just in 1 month. So let's say you want to go outside and see an object, but you don't want to stay up that late. Let's say your cutoff is 10 o'clock and it's not going to be really in a convenient place to see it till midnight. No problem, wait a month. A month later at 10 o'clock, it'll be where you want to see it. And so it goes. So there's 2 things to keep in mind: what's going to happen over the course of an evening and what's going to happen throughout the year, because the sky changes with the seasons. But you do return. You get back to the winter. If you miss something in the winter, don't worry, you'll get back to it. You just may have to wait a while. Okay, so that's the motion of the night sky. Now a few words about the layout, and then we'll start our tour. We have 2 big things, 2 highways in the sky that I mentioned, and they are the Milky Way, which unfortunately we can't see in San Francisco, but if you head out to a more rural area, you see a darker sky. There's the Milky Way. On this picture in March, it looks like it's going sort of north and south. It doesn't always have that angle. Sometimes it's more across the sky. That's because of the Earth's tilt as the Earth goes around the sun. But it's always going to go through the same constellations and have the same relative position in the sky. The other highway is the ecliptic. The ecliptic is the path that the planets appear to move in. On this map, we actually have a planet, and that planet actually, this is the map for March, is up there right now, and that is Mars. So about 1/3 of the way in from the right, Mars, along the ecliptic. Now the planets, generalizing, it's not always exactly this way, but in general, they're sort of going east. This is different from our eastward motion of stars rising in the east and so forth. I mean, literally heading across the sky from night to night very slowly. Right now, Mars is over here, but eventually it'll be over here in a different constellation. And then it'll be over here and still another constellation. If these constellations look familiar, Taurus, Gemini, Leo, they are actually also known as signs of the zodiac, because the ecliptic and the zodiac are roughly the same thing. You might say the ecliptic is sort of a line through the center of the zodiac if you think of the zodiac as a band. So the planets are in their own orbits. They're always moving relative to the Earth. And unlike the stars that'll be the same every year at the same time, the planets won't. And you just need to determine what the position is, but knowing that they're in the ecliptic and knowing how to find the ecliptic helps you tell the stars from the planets. I mean, generally stars seem to twinkle, planets less so, but another way of telling them apart is knowing where the ecliptic is. And there are also some stars that lie along the ecliptic. So those are the two big markers in the sky, and we'll come back to that as we get into our tour of the night sky. So let's begin. I should have added one thing about the ecliptic. The moon seems to travel in the ecliptic too. It's got its own orbit around the Earth. The planets all are in the same plane. It goes back to how the solar system was created from a disk. The planets all basically kept the same alignment. That's why it looks to us, looking from the side on planet Earth, that they all travel together in that line of the ecliptic, or roughly. Okay, sky tour. Let's start our sky tour. We always start from the same place. We need to get our bearings. We need to know which way north is. North is where the North Star is. Now, it'll save you some time if you sort of have an idea of which way north is already. You might want to get your cell phone out, and I know iPhones have a utility that's a compass, just kind of figure out which direction it is. But to be more exact, to use these familiar patterns, we use the Big Dipper. That's the easiest one to use. And the Big Dipper is not a constellation. It's part of a constellation. It's part of Ursa Major, a much bigger constellation that's supposed to look like a bear, but frankly, I don't think does. But the Big Dipper looks like a Big Dipper, so you can always remember that. You go to the end of what looks like the pan of the Big Dipper and draw an arrow, and that takes you to Polaris, the North Star, at the polar axis. This is what everything revolves around, directly above our North Pole. Polaris is not a terribly bright star, but it's not dim. It's second magnitude, so it's the only thing there. When you draw that arrow, you won't have to decide between 4 different things. You'll just go right to Polaris usually. If you're in doubt and you have the Skyview app on your phone, you can always confirm it, but you'll probably have, pretty soon you'll find it very easy to find Polaris. If the Big Dipper isn't visible, maybe on this particular night, the Big Dipper is down here, because remember, everything's always changing throughout the year. During the winter, the Big Dipper tended to be more down towards towards this horizon, the north horizon. So let's say the Big Dipper was down here. Go to the other side where we have a W. That's the constellation Cassiopeia, a W. Some people think it looks like an M. Your choice. I go with W. So if you notice, there are the 2 V's of the W. One's a sharper V, one's a more relaxed V. If you bisect the more relaxed V, take a point between the 2 edges of the V, and then just draw an arrow. You don't get right to Polaris, but you're not too far off. So this is another way to get to Polaris. Once you have Polaris and you're aligned, now you can do some other things, which we'll do in a minute. Okay, so just one more slide here. We'll show the same thing on the planisphere. So here I've marked out the Big Dipper, Cassiopeia, and here's our arrows. The end of the pan bisecting the V, both get us to Polaris. Now, we've seen the charts, so let's try this ourselves. Now, this will be a little more difficult because no lines, no labels, just you and the sky, all right? So let's see if we can do this now. We want the Big Dipper. Let's try to find the Big Dipper. I would say it's over here. Let's give it a try, okay? We need the pan of the Big Dipper. There's the pan. Now we'll do the handle. There it is. And let's just, while we're at it, let's find Cassiopeia 2, the W. Here's one V. This is a more relaxed V. This is the sharper V here. Okay. Now we need some arrows, right? We're going to draw arrows. So let's start with the Big Dipper. We're going to use the end of the pan and see if we can find Polaris, the brightest thing in the path of our arrow. That's got to be it. Let's try it now from Cassiopeia. We just sort of eyeball this, kind of bisect the outer side of the V. Okay, I'm just going to take a stab at it with this arrow. Let's say like this. Yep. Okay, so not quite as close to Polaris, but close enough. All right, so we've done it. We found north. Down at the bottom, this confirms we are looking north. This is absolute north, not like magnetic north on your compass, absolute north. So we've done the northern part of the sky. Now, let's go on and start our tour of the winter sky. Here's what we're going to do. We're going to face north, which we just did. We're going to find Polaris, which we just did. Then we're going to turn around and face south. And we're going to find Orion, which is very recognizable, very easy to find, a good place to start in the southern sky. And then we're going to find the stars of the winter hexagon using a mnemonic, CARS PP, C-A-R-S PP, stands for the first letters of each of those stars. Okay, Orion, now we're back to this sky map. Orion's sort of towards the south. So we were at Polaris up in the northern sky. Now we're down closer to the south. We're facing south probably if we're looking at Orion. And it is just a dead giveaway, Orion's belt. I mean, there's nothing like it in the sky. 3 stars in a row, bright stars, about the same, the same brightness. And then there's 2 other bright stars flanking it, Rigel and Betelgeuse. And then as a bonus, in a separate constellation not far from Orion is the brightest star in the sky, Sirius. So this is what Orion's supposed to be. Orion is supposed to be a hunter, is a hunter. And here he's got his club up, raised high. He's confronting Taurus, the bull. He's holding a shield out in his left arm. In this picture, he's kneeling. The constellations stay the same. The art, the images here are a matter of interpretation. This is the constellation art in Stellarium, the planetarium program I told you about. But if you see a different kind of image that's a hunter, as I said, there's no agreement on exactly how to portray Orion, but there is agreement on what's part of Orion. So here's the belt in the middle. It is 3 stars in a row. Can't miss it. All visible. There's nothing else like it in the sky where you see those three stars. Then the two bright stars that are on our list, Rigel, a bluish white star down here, and Betelgeuse up here, are kind of an orangish reddish star. These are just tints, but in reality, it's a red giant star and Rigel's a blue giant star. Okay, so let's then go on to the vision of the night sky. This is magnified a bit so we can see it, but this is a screenshot taken from Stellarium of Orion. So what we have here is let me just sketch it out so it'll correspond to these other things. I think Orion looks like an hourglass that's sort of skewed off to the side. Other people see maybe two triangles stacked on top of each other. Doesn't matter. Again, in the middle is the belt. And hanging down from the belt is Orion's sword. You see this kind of blue smudge here. That is actually, part of that is the Orion Nebula. That faint fuzzy we looked at earlier. Okay, I'm not going to sketch the rest of it, the shield, etc. But this is the classic Orion. And then the brightest star in the sky over here, Sirius. So we're going to find the winter hexagon now, using the mnemonic CARS PP, which again stands for these stars. The winter hexagon is what it sounds like. It's a six-sided object. And each point on this is a different star. So if you find all these stars, you've found the hexagon. We start at the top with Capella, a bright star, second brightest star in the sky. Go down to Aldebaran, an orangish star. Down to Rigel, we've already seen Rigel. That's the blue tinted star that is Orion's left foot. Then down to Sirius, the brightest star in the sky. Then back up to a star called Procyon. Kind of easy to find because it's sort of out there by itself, or that's the way it appears. Pollux, another easy to find star because it's part of two stars in a row, the heads of the Gemini twins. So let's see how this looks now on a map. Here's back to our sky maps. So each one of these purple blocks represents one of those stars. No, here's one way to approach this. Orion is a giveaway because of Orion's belt. It just looks unique. Sirius is right below Orion, a little to the left here. So if you've got Orion and you've got Sirius, you've already got two stars. You've got Rigel and you've got Sirius. You know Sirius is at the bottom of the winter hexagon. Capella's at the top, and it's the second brightest star. So you can almost just zoom up and find Capella and then complete the rest of the outline. I'm not sure about Capella. Try going from Orion's belt right up through his shoulders. It'll take you straight to Capella. Here's a tip. Really look up there. Go big. If you can't find something, go bigger. The sky is big. It's a long ways from Sirius up to Capella. It doesn't look that way on the map, but believe me, when you're out under the night sky, it looks like a long ways. Once you've got Capella down, then just go around. You're just going to go down to Aldebaran, down to Rigel, Sirius, Procyon, Pollux, done. Here we are in the planisphere, what we've already seen, winter hexagon. Okay, with the 6 stars of the winter hexagon, plus 2 other stars that we've seen too, Betelgeuse, and Castor was the other Gemini twin right next to Pollux. So now we're up to 8 stars. We need 1 more for the winter sky, Regulus. Here's how we find Regulus. We take our friend, the Big Dipper, we use the other end to find Polaris. Now we go to the other end of the pan and go down till we get to the ecliptic. The dead giveaway is the backwards question mark. that's part of Leo, the backwards question mark. If you've got the arrow and the backwards question mark, you've nailed Regulus. Some people would say a sickle, whether you call it a sickle or a backwards question mark, it's very distinctive. So, so now we have all of the bright winter stars. We have the stars of the hexagon, Betelgeuse, Castor, and then we have Regulus coming down to the bottom of the backwards question mark. Uh-oh, okay, all the labels are gone now, so we have to remember what we did. Here's a tip. First of all, we're looking south, and secondly, over on the right, this very bright object is the moon, okay? But the other things are stars. So Orion's belt, obvious, right here. Sirius down below Orion. Sirius, the brightest star, Capella, the second brightest star. So if we start at the top, we'll go down to Aldebaran, but wait, we've got two orangish objects here. Remember on the map for March, Mars was there. Mars was actually above Aldebaran. On a clear night, you can also see a sort of a V structure over here to the right, which is the snout of Taurus the bull. So it's the lower object that is Aldebaran. But I have to say, with Mars up there, it's been a challenge to figure out which is which. Then we go down to Rigel, part of Orion, then back up to Procyon. Remember I said it's just sticking out there by itself, nothing around it. Then we've got two stars in a row, Pollux and Castor, the Gemini twins, go up there, and then back up to Capella. Not a nice, neat hexagon, but it is a hexagon. As the stars travel across the sky, sometimes they look a bit skewed. This is the winter hexagon heading over to the west because it's the end of winter, early spring. Okay, Regulus, shall we do it? We've got the Big Dipper up here. We're going to use the inside pan here and see if we can draw an arrow down to the bottom of a backwards question mark. It's got to be right there. And here's our backwards question mark, or sickle if you prefer. I'm simplifying it a little bit, but there it is. So all the bright stars of winter. And you know those stars, you know how to get to the constellations they are in. Now, one more before we leave winter. We talked about deep sky, faint fuzzies. There are two in winter still up there. One's a star cluster, and it's called the Pleiades. And it is appears to be like this little cloud up there that's too small to be a cloud. It's a faint fuzzy. It's really 7 stars. They call the 7 sisters. You could see this in binoculars, and maybe on a dark night, make out some of it, but it's an amazing star cluster, very accessible, fun to view through binoculars in particular. And then we have the Orion Nebula, another faint fuzzy Orion sword down here, kind of purplish in this picture. With binoculars, you can see more of it. Okay, we're over to spring. Now the sky has changed a bit. We're into the spring. What's happened to our winter hexagon? It's over here now on the right. It's setting in the west. We can see Capella here. See how it's sort of spun around? Remember I said as the sky rotates, sometimes things get skewed. So it's now on its side, but it's really setting in the west. But in the spring, now we have the Big Dipper up there at the top, and we're going to find Arcturus by, instead of using the arrows that we've been using, we're going to arc. These are the red arrows, arc to Arcturus, which will be the brightest star in the sky if we can't see Sirius. And then we're going to keep going to get over to Spica. We're going to spike to Spica or speed on to Spica. Arcturus, I think, is so bright you won't have any trouble finding it. It is in the constellation pleiades, which is, it looks to me like a kite, actually. I'm running the little red dot over it. Some people think it's an ice cream cone. Okay, well, it's one or the other. Again, this is one of those familiar patterns in the sky. Now, what about the summer triangle? Spring triangle. Well, it's a triangle formed by Arcturus and Spica, which we just found, and then Regulus, which we found before, resting over here on the ecliptic, this time below the backwards question mark or sickle. So these are the bright stars of spring, really Arcturus and Spica. Regulus we saw in the winter. It's still very viewable here in the spring. Okay, so just briefly here, let's but we're running a little behind time-wise, but let's see if we can do this, okay? We've got the Big Dipper. We're going to arc from the handle of the Big Dipper to Arcturus, and then we're going to speed on our spike up to Spica. Now we need a spring triangle. So Regulus, here is our backwards question mark here. So that's Regulus, we found it. And so if we just go from Spica to Regulus and then back to Arcturus, there's our spring triangle. Now over to the summer. Okay, here's what we're going to do. We're going to start as we started before, and we've already done this, find the Big Dipper and Polaris. Arc to Arcturus, we just did that. Spike to Spica. And then while we're down there, sort of in the southern sky, we're going to scan over and find Antares, a reddish star, bright star in the southern sky. Then we'll come back up and finish off with the summer triangle. Okay, so we're down in the southern sky now. I'll turn the planisphere over, look at the southern sky. Spica is over here on the right. And so I've got the little red dot over here, and I've also marked it with a purple square, Spica. So if you just scan along the ecliptic, you come to a bright star. I think it's easy to spot because it's the only reddish star in this area. Antares, just below the ecliptic. But it's also in the constellation Scorpius. And most of these constellations don't look like what they're supposed to be, but I think Scorpius looks like a scorpion. It's got 3 bright stars at the end that look like a stinger. It actually looks kind of mean, I think. And another way of viewing the bottom part of Scorpius is it looks like a fishhook. Here's another one of those patterns, a fishhook. But if you're still having trouble finding Antares and you find yourself over in this part of the sky with something that looks like a teapot, here's the teapot. It's part of the constellation Sagittarius. And again, we're also going through, since this is the ecliptic, these are the signs of the zodiac: Scorpius, Sagittarius, Capricornus, etc. So this is an object that looks like a teapot, and that's its popular name, the teapot. We're really in a rich part of the galaxy here, the Milky Way, when you can see it is really bright and a place to see a lot of deep sky objects. All right, so that's Antares. Now just quickly here, we'll draw this. So you can't really see Spica. It's over to the right, or I don't think we can. I think, yeah, it would just be off the chart here. But as we're scanning across the sky, here's this bright object that looks reddish, Antares. And it's in something that looks like it winds around. So it is, in fact, Scorpius. So we got the fishhook down here. Whoops. There's the fishhook, and it continues up here to this the top. There's a kind of a, I'm not sure I have that quite right, but anyway, so that's sort of Scorpius. And then over here is your teapot. Oops. Now the summer triangle. So we'll go back north now. We've got the Big Dipper over in the lower left side. Arcturus is opposite. The summer triangle is not one constellation, but 3 and 3 stars, 3 bright stars. My mnemonic is Dave, D-A-V, Deneb, Altair, Vega. Vega is going to be the brightest after Arcturus, then Altair, then Deneb. I think fairly easy to spot, but if you're in doubt about Deneb, since it's not quite as bright, Deneb's also part of the constellation Cygnus, but there is a pattern within Cygnus that looks like a cross, and the nickname for this is the Northern Cross. And then Deneb down at the end. So Deneb, and then up to Altair and over to Vega. The summer triangle, remember, go big. It looks big. It looks small on this map. Under the night sky, it looks big. Okay, it is almost 8 o'clock. I'm going to try to finish up here and then we'll take some questions. So we have the summer triangle here. Now remember, Deneb's going to be here with the cross. I'll also kind of try to superimpose the cross, Northern Cross here. But the triangle is linking these 3 stars, Deneb, the brighter one, Vega, and then Altair. And of course, the Big Dipper, we've already arced to Arcturus over here. I'll just point to it, Arcturus, Spica, to orient you. So that is the summer triangle. And real quick here on the fall, there's one star left, Fomolo, off by itself, the lonely star way down in the south. So far in the south, I can't even get it on the front part of the planisphere. There's something called the Great Square of Pegasus. If you take the western side of that and draw an arrow, keep going with your arrow, you'll find lonely Fomolo down here close to the southern horizon. Okay, so here is the fall sky, and lots going on here. This is kind of looking up at the sky as if you're lying down because we have so much distance to cover. But here's Cassiopeia, all right? So you find the Polaris down here. Over here, this is the winter hexagon. We're in fall now. The winter hexagon's coming back up. All right, Capella, Aldebaran, etc. Can't see much of it, but it's coming up again. And the summer triangle, it's still here, but it's going down. It's heading to the west. As the hexagon gets higher, the triangle will get lower. All right, so let's find the Great Square of Pegasus. It's here, it looks big, doesn't look big here, it does look big under the night sky. We'll take the western side and we'll go to Fomolo. Okay, so next steps. That's the end of our sky tour. Next steps, practice. Print your sky map out tonight. Go outside. Start while you remember this. If you don't remember everything, hopefully remember the method, and you remember enough to fill in the blanks and find these patterns in the sky and these bright stars. And then as you continue on and you get more familiar, gradually increase your familiarity with the constellations. We've been sort of introduced to more than 16 of them tonight. So build on what you know. Use these constellations to find other constellations of interest. Get to know some of the stories and myths. There's some great stories. Cassiopeia, oh boy, Cassiopeia, Cepheus and their daughter, oh my God. What do you find out about that? And Perseus? They're all together in the sky, and it's a very memorable story. Explore neighborhoods. We did that with Orion. Orion's next to his hunting dog. Canis Major, that's where Sirius is. He's there with a bull. He's got another dog. That's where Procyon is. Down at his feet is Lepus, the hare, the rabbit. So it seems like a group. It sort of all goes together. And that's the way it is with a lot of these constellations. That's how the ancients remembered these things. They didn't write them down. They didn't have maps. They had stories. And if you link these things together through stories, it'll make more and more sense to you. Finally, if you do have binoculars, use them to explore the sky, check out the moon, check out the planets, check out what deep sky objects you can find. Do not buy any new binoculars until our second class. Finally, attend the next sessions. Next one, choosing the right telescope or binoculars to suit your interests, circumstances, and budget. For people who don't have a telescope yet, but maybe for some who do but never used it and would like to know more about it. The next class will be the setup and operation of what you bought or borrowed. And then finally, an introduction to astro imaging. We don't have dates for these, hopefully at about 1 month intervals. Questions, you can email me at vicepresident@sfaaastronomy.org. And here's our website address too. Lots of information on our website. Okay, I almost did it. It looks like I'm 3 minutes over, but I have, you know what they say, did you save room for dessert? I saved room for questions. And by the way, don't feel you have to stay on the call, but if you have questions, I'd be happy to try to answer them. Okay, Liz, are you here? Well, Liz, can you hear me? Well,
Thank you, Bill. It was very good.
okay, thanks, Mike. I'm going to, Liz was going to help with the chat. It looks like she's not still on the
Can you
call,
see the other?
but I can see the
There
chat.
are, yeah, there you go.
Let me just, I can read the chat. Why don't I try to handle some of these? Okay, how do you well, maybe there's some more questions about that. Let me see. Oh boy, there are a lot of questions here, aren't there? Okay. Okay, we are recording this webinar and the video will be available. Share the PowerPoint. I'll see if I can figure out a way to do that. Jessica advises one of the photos is from the Rock Springs parking lot. I thought it might be. Okay, Orion, yeah, it stays above in the winter. Okay, that's good to know. Let's see. Yeah, I think in terms of the recording, I think it'll be viewable on YouTube. And the instructions may be on our website as to how to view it if you want to rerun it. Or you know people who missed it and would like to see it. Yeah, it'll
Bill,
be
there's one
published
question
on
here.
YouTube.
The
Pardon me?
question is, there's a question here, what other galaxies other than Andromeda can we see with the bare eye or with binoculars?
You know, in my own opinion, none of them. But one of our members who's very big on binoculars tells me that through binoculars, you can see some of these others. I just haven't been able to. Now, better binoculars, sure. Yeah, astronomical binoculars, but I'm talking about the kinds of binoculars you may have around your house. If you can find them, they will be pretty fuzzy and pretty faint. You won't really see the kind of detail that you could see with the telescope. So that's why I recommend just starting with Andromeda. How do you find out whether there will be fog? Well, the weather report, there actually on our website is a utility that will tell you the weather on Mount Tam and how the viewing conditions will be. Unfortunately, there's a lot of fog in San Francisco in the late summer, as I'm sure most of you know. What telescope do I use? I have a Celestron 88SE and I have an EV scope. And the pictures I took with the EV scope. That's a hybrid between a telescope and a camera. Have I used Sky Safari to control my telescope? I did, and I gave up on it. It just wasn't precise enough for me because it operates over its own local Wi-Fi. And if you're at a star party and everybody's using Wi-Fi, I just found out it didn't work very well. But others may have had more success. You know, and in terms of what other galaxies you can see, I would go on the internet. There's quite a bit on there about using binoculars, and there are different opinions. So what I'm saying is I just haven't had a lot of personal success, but there may be other things you can do for galaxies. Okay, I think that's I think I've covered the questions that I could find.
Hey, Bill, it's Liz. Can you hear me
Oh, hi,
now?
Liz. Yes, I can. Hi, Liz.
I'm so sorry. I had an audio problem and I couldn't get back in. I couldn't get myself unmuted. Thanks. You did a great job with the questions and you did a great job with the presentation, I think. One of the things I thought was interesting is when you brought up of Orion and you said there's been no agreement on how to portray Orion.
Right.
I think that we all sort of think of it as Orion the hunter and he's wearing sort of a tunic and the nebula is his dagger. I just wanted to share, I was listening to a presentation by the Royal Edinburgh Astronomy Club, and in true Scottish perspective, they talked about Orion and that of course he was wearing his kilt and that was his sporran and not a dagger. So, you know, it seems that astronomers around the planet can't quite agree on quite how Orion is dressed or what he looks like.
Yeah, you know, there is international agreement, and there has been for a long time on the constellations themselves. Each one is an area of the sky. It's like the states in the United States. Each constellation has its own borders, just like each state in the United States has its own borders. And it's important if you're at a more advanced level because a lot of the stars are named in reference to the constellation in whose area they reside. And so it's interesting that there's so much precision in terms of the borders and the naming, but no agreement on the art. And it looks like in the picture I showed you that he's kneeling, but I've seen some where he's standing. And so they're really both his feet. Anyway, you get the idea. He is a hunter. And
Absolutely.
Right.
Well, Bill, I think we had some experienced amateurs on the Zoom this evening, as well as probably some people who had less experience, like myself, and I learned a lot. So I know you put a lot of work into it, and I'm really looking forward to your next session. And thank you so much for doing this one.
Okay, well, thank you, Liz, and thank you, everybody, for joining us. I had a lot of fun doing this. It was a fair amount of work, but I did have fun doing it, and look forward to the next session. So,
So, and just to be clear on that, you said that we're going to clarify the date. So as soon as we have that nailed down, then everyone can look forward to sort of the same communication path that we had for this one. We'll have information on the SFAA website. We'll have an email that goes out to members. We'll have information on our social media accounts, Instagram and Facebook. We'll make sure that we get into the Bay Astro email from Ken Lum. And of course, we'll have it posted on Eventbrite. So hopefully that will be how everyone who's on the call tonight was able to connect. And then I think we've already mentioned that this session tonight will be very quickly streaming for anyone who wants to watch it again on the SFAA YouTube channel. So please feel free to go look at it again.
okay, and I'll
Got a lot of people
check
here who
on,
have said great presentation, and thank you, Bill, and I echo that. I think it was great.
yeah, I'll check on the PowerPoint options, how that might be made available too. But in conclusion, thank you everyone for joining us, and we'll look forward to seeing you next time.
Sounds good.
Okay.
Bill, can you and Jessica, maybe Thomas, stay on for a minute after everyone disconnects?
Sure.
Thanks, everybody.